Hello, everyone. Welcome to episode 139 of the Data Science on this session, right? The Data Science on the episode. How are we all doing? My name is Pablo. I am your host for the Data Science Sunday. This Data Science Sunday episode. Welcome. First off, introduce myself. I'm a data science professional, a data science instructor. I build data science communities. Um, I am a curriculum manager. I take data science skills, model them into learning tools, and design them into learning tools, and pass them off to learners that can now approach the future of work with it. Right. I also head the data science community at Collab Innovation Hub. I'm also the director of people at Collab Innovation Hub. And what we do at Collab Innovation Hub is to build a tech ecosystem, and that's what we are doing: building a tech ecosystem, a place for every tech enthusiast, anyone trying to build their tech skills, build a startup, work for startups, build products, build labs, or leverage on labs to solve human problems. The collab ecosystem is typically where you should be. And we make this possible with several infrastructures, with several pillars. On several pillars, we have infrastructure. At Collab Innovation Hub, you typically come there and have power almost always. You have internet almost always. But one of the second infrastructure that is powerful is the community. To validate what you have learned, to build, you need a community around you. So that's why we have our tech skills, our tech talent around the community, so we could drive them through the ecosystem and make them succeed in different areas within their community or on a global scale. Now, to that end, we've basically created a Data Science Sunday, and the Data Science Sunday is a virtual community for folks learning data science from scratch. And we use every Sunday, 2 hours every Sunday, to build this consistency. The Data Science Sunday episode started. The first episode was on the 6th of November 2022, and we have been on this episode since then. Like, we're fortunate not to have missed any episode yet. So that means if you're here, if you've been with us since the very beginning, you've had more than 200 hours of learning, and that's massive, right? Who knows? Maybe we're probably heading towards the 10,000 hours of learning. But what that means is you have a community around you to learn stuff, so you don't feel lost. You have a community that validates your skill set, and that's what we typically need. We need real communities around us when we're learning stuff. So yeah, enough of the administrative side of things. So in the Data Science Sunday episode, every Data Science Sunday episode has interesting things around it. For every Data Science Sunday episode, we have 2 sessions. The first session is an interactive session, which starts from 6 o'clock West African time, right, to 7 o'clock West African time. We encourage folks to talk about their challenges. We encourage folks to share what they are learning. We encourage folks to talk about a lot of things. These conversations cascade into really important realizations. Like today, we're going to talk about, I like to share about the idea of how long you think you have to wait to become really great at what you do in the tech space. Would always like to talk about what it means for you to put yourself out there in the tech space. Such conversations, because a lot of people are out there just looking to build and go out there, earn a living for the most part, be part of those who are the techies and who are making changes in the ecosystem and who are earning top dollar, right? So conversations like this help. Now, the second session in the episode is from 7 o'clock West African time to 8 p.m. West African time. That is the technical session, right? The technical session is where we try to do a little technical. Now, for the past a year, um, for the past 2 years, and by November it will be the third year, right? We have been learning from the very beginning. I remember the very first data science Sunday session on the 6th of November, and we talked about creating a Python variable. And today, in today's session, we're going to be talking about a simple unsupervised machine learning example. Yeah, so we've come all the way learning all these things to down to machine learning, and soon we're going to go from machine learning to deep learning, and deep learning to also AI and all. And so it's really a great this is a great opportunity for us to look to see how growth occurs and all, and how it's important to stay hungry throughout this period, and have that staying power. So that's basically what we're going to be doing today. Have this interactive session, jump into the technical session, and then that'll be it for now. Then we'll do it again on another Sunday. Right. Just so you know, this is the 28th Sunday. This is the 28th Sunday of the year. And it's pretty interesting to see how you can go from, I think this year Sunday we have 52, excuse me, we have 52 Sundays. And this is the 28th Sunday. Right. So we're here. So typically I'll ask questions like, if it's your first time, please feel free to share with us, right? If it isn't, but if you've been here before, also feel free to let us know what you do. Like this week has been really interesting for me. There's a lot of things I'm doing, and I think that I'll give you snippets of it. Like I've been working so hard on the curriculum management side of things, where I have to redesign a data science curriculum, right, so that it could be forward facing and the new challenges that we have in the tech space, stuff like that. This week has also been interesting because I was recovering from like I had more than 10 days of illness, and so recovery has been really interesting. And then having to teach again, because it was something I didn't do physically for a bit, and it's really interesting. And also trying to meet deadlines, because I had fallen short when I was ill, and just trying to meet up with stuff. I would also share snippets of the changes that I'm trying to incorporate into this curriculum redesign. My hope is that to give you guys a sense of what's changing in the data science. Not that it's changing, but what is coming into what's being put into context, right? As you learn data science. So yeah. So these are a few things we would look at and talk about in the very beginning. Now, while we're at the beginning, just as I'll be sharing a few things. I'll try as much as I can to share a few things I think would help. And then hopefully you share what you have to. You talk about what you're doing. If it's your first time, please let us know. Tell us where you're starting from. Tell us your fears. Part of what we do here is to douse the fears, and then keep pushing, right? So please let me know if it's your first time here. Please indicate. If you want to talk about it, please feel free to just raise your hand. You can also, you want to talk about what you've learned this week, feel free to. And you want to say, oh, I don't know what the hell is going on Data Science Sunday. I just came in. It's my first time here. Feel free to raise your hand. You want to say, look, I don't know. Oh, okay. Go ahead, Jacob. Jacob Joseph. Please, you raise your hand. Feel free to tell us.
Okay. Hi, good evening, sir, and good evening, everyone. Can you hear me?
Yes, I can hear you loud and clear.
Okay. I sincerely want to appreciate the opportunity to be here. I just want to indicate that today is my first time, and I am coming
Go
in
ahead.
with the strong belief and with consistency. I know, hopefully, if I'm carried along, binge.
You're welcome. You're welcome, Jacob. First off, you're going to, if just keep it going. That's the very important thing. Keep it going. Every day there's something every Sunday I receive newsletters from the Knowledge Project. That's Shane Parrish. He has this stuff called the Knowledge Project. Farnham Street. They share snippets, knowledge bits on, what human beings or what we can do to, get along. And I'll share something with you that I think is really, yeah, important. It's called the brain food, right? So they just share snippets of a bunch of things. So today there's some that was shared, um, and I'll share two things. One, the first one says they are called tiny thoughts. So in the newsletter, it's called Brain Food. There is a free online read, so you can read up stuff, which is curated by Shane Parrish. Look him up. Um, and there that is broken down into tiny thoughts, insights, and then the knowledge project, right? And then just to share something that in the tiny thoughts section. Now, in the tiny thoughts section, there's some that says, while the rest of us are chasing victory, the best in the world know what they must avoid losing before they win. Now, a lot of stuff like this are really thought provoking, right? And I like to share why I think these things make a lot of sense. For instance, we're all in the tech space, it's common knowledge that people are looking for the next best job. Folks are trying to get themselves ready for the next best job. Sit in front of a computer, write code, talk about things they know or things they don't know, tell some lies, you know, construct their CVs in a way that it's either what they have done or what they have not done. But this conversation tells me a lot. It says that while the rest of us are chasing victory, the best in the world know what they must avoid losing before they can win. And in my thoughts, especially for you, Jacob, I think one of the things you should learn is you should learn at this point to know what you should avoid losing. And when you say avoid losing, is my head, this is what I think. I think in your journey, just like you mentioned, consistency. Remember not to lose each day, lose the opportunity to learn something every day. Remember that not to lose the opportunity to be in an environment that encourages you to chip in or get yourself locked in. That's how I see it. It's basically an interesting thing when you start. There's a lot of opportunities, but just as we have the greatest advantage of being in the information era, it also comes with a disadvantage, really. There's so much information out there. So you also have to learn not to lose yourself in the information flood. Really, really super important. With the information flood leads a lot of distractions, folks. Attention is one of the greatest resources ever. One of the greatest resources you have, attention and focus. But we have infrastructure, we have tools that are built today to take our attention, right? And if the people who succeed are the people who learn not to lose focus. So that's how I see the stuff that was shared by this tiny thoughts. The last one I'm going to share is, it says it doesn't matter what position you find yourself in right now. What matters is whether you improve your position today. Every ordinary moment is an opportunity to make the future easier or harder. Again, I like this stuff because I think it's telling. When I started my data science journey in 2017, I like to call the beginning 2018 because that's when I joined Collab Innovation Hub as a subscriber. In 2017, when I started, there was a lot my mind was going through my mind. For instance, I have to ask myself questions like, will I even succeed at this? Or you have to ask myself, are there people who are succeeding at this? And can I do stuff that makes myself look like them? And then I joined Collab, and then there was the realization that I had to build skill for a long time. Now, there's something that's really interesting about Collab Innovation Hub. You get to see like the founder. In the first 2-3 years at Collab, the founder was almost always available. At that time, Collab was growing. You know, by the way, Collab will be 10 years next year. So at that first 4 years, from like 2016 to 2020, you would almost, in fact, 2016 to 2021, you would almost always see the founder is always around. And he always used to share how to position ourselves, because he has this saying that says, your competition is global. So you almost have to look for how to position yourself for anything you do. And so we learned the beta lesson that every day matters. And I call it a beta lesson because most times you just keep trying to prep yourself to look like what you're not. Meanwhile, what you're supposed to do is take every day to improve your position. And when you're improving your position is to look at the things you have and ask yourself what's weighing you back, what mentality is poor, what activities would you do that if you did this activity for the next 5 years, you would be in a massive position, right? So and so that's the part that says every ordinary moment in life is an opportunity to make the future easier or harder. And I think Jacob, you have every not just Jacob, everybody has that opportunity. I recall before again I let folks talk about stuff. I'm sorry that I'm saying a lot, but I recall one of the first times I got paid in tech, right? And those moments are always interesting because you celebrate it a lot and say, hey, I had this huge pay and this is what I'm going to do. But there was this stuff that we learned at Collab. Like the founder of Collab has almost always had this infrastructure of alternative power using lithium batteries to power the hub. And to that end, the Collab CTO, I remember he got a job in one of the startups that is one of the major fintechs now. And I recall that the instance he got the job, there was this guy, Namdi. Namdi now works at Cloudflare in Germany. He's a part of the Collab community. Namdi knew how to set up, solar batteries and all that. And so Namdi helped him do that. And I recall asking him why he had to do so much just because he got a remote job. And then he goes, and then the founder Sanusi and Robert were like you have to almost always set yourself up so that those things that that gives you a little edge in your work is always there. And that's when it hits me, right? And if you look back, and then I started to pay so much attention to what the collab founder was doing there. He started investing in alternative power since like what 2011. That's wild, right? Because he told himself that there were situations he didn't want to be caught up in, like having really huge storage for water, having alternative power, so that at any point he will be able to get things done. And so if you go to Collab, there are some places you see some small gadgets for power, and those were the ways he started trying to ensure he had lights that could power his laptops continuously. Those were ordinary moments that I think shaped Collab, and I believe it shaped him a lot. And it has also shaped me. That's why it's important that when you grow in this space, you look for really, really cool, very small things that you can do that will shape your future, right? So again, I'm sharing this to all the learners. At a point, a lot of us started just investing in alternative power, even if it meant just buying one battery and then buy one very cranky solar charge controller, and buy one cranky inverter, all just to set ourselves up and be sure that when we came back from Collab, we could manage at least 4 to 5 hours of power and do a few things. So these things are important, and it might not just be the inverters or stuff. It's also the things you do, the activities you do for yourself, how you learn to read, the time you set up for this yourself, the activities you cut out of your life just to ensure you have this consistency, the communities you find yourself in, and how much you invest in helping others develop in these communities. These things are life-changing things you do, and they'll provide that moment for you in future that makes it easier for you to navigate from one tough situation to another. So yeah, so that's that. So welcome, Jacob. Anyone else? Do you have questions? Yeah, you have questions? Is this your first time? Are they stuff you're thinking? Are they questions you have? Are they mind-boggling things? Are they things you look at and you wonder if it will ever happen for you? Please feel free to ask. This is what the session is. All right. So all right, Shina, please go ahead.
Hi everyone. Good evening. Am I audible?
Yes, I can hear you, Shina. I can.
I think what I want to say first of all is that I started data science on the October 2023. I think about that time. So I think a lot of times it may be probably slow comprehension or just trying to see things from a different perspective at times, or just probably in one bubble and trying to bust the bubble and enter another bubble. But I like somebody else said earlier, I appreciate the fact that I learn something every day whenever I come on Data Science Sunday. And when I say I learn something every day, it goes into my own storage data bank of what you've done. And just like you said, I also been following the Farnham Street that you mentioned about, and one of the things they said today was every day you have to know that you have to add something. I think, let me see how they quoted it here. They said that
it doesn't matter what position you find yourself right now.
Yeah,
what matters is whether you improve your position today. Every ordinary moment is an opportunity to make the future easier or harder.
Yes. So I had taken that as part of what I do every day, because I think recently, that was in April, I started the data collection job, which you are aware about. And and it's part of what my team, whenever because I get a new team every week, they always find out that working with me as a team leader, I try to see how I can make things better for the team and for mindsets as a company which I work with. So in addition to that, I started listening to Finance Beat. I think this is the mind project or the project something mind. I always forget, but
No,
I just
the knowledge project.
yeah, knowledge project. Thank you. Yeah.
Yeah,
Yes. So I think a lot of us who are in tech, it's not actually directed towards tech, but it gives you an idea of perspectives or mindsets. So a lot of people maybe slow to catch up on some things, but listen to other people's stories, like something you said earlier about uh, what's not what to avoid losing before we can win. Because
Yeah.
I think one of the recent podcasts that he made talked about the CEO. I think the CEO of I think CEO of Spotify or CEO one of these Shopify. Yeah, I think CEO of Shopify, where the guy is more like he's an immigrant and he knows what the background is like. So we all have to, like, just like what Pablo said earlier, you should not found losing some particular things like discipline, timekeeping, because in Africa there are things that we overlook a lot, which affects our place as global workforce. So if you can put something in place which are not in their normal way of life, we get to key into the global culture. So I think I just want to encourage everyone. I'm also still on my learnings is Tableau, and I'm still on my sampling part. I've completed my AI strategy course, which I don't said it probably last week. So I'm still learning every day. So I'm a lifelong learner, as Pablo says. So I just want to encourage everyone there that what you have as your target, make sure you don't lose your every day, because what I want to close on is that I pick August every year as my own metrics or analysis month. So some people do it in December, some do it January, but I pick August, and I think I wrote about my own last August on Medium too. So if you're consistent on something, see what you've achieved in the last 12 months. Always pick a time that you can sit down. If it's either monthly or it's either 12 months, 3 months, and then look back and see what have I achieved in the last, because every day counts. So if you miss one day, make sure you add the other day, because once you make too many days, it piles up. So it's as I say, it's consistency, but we have to build that culture too. Thanks, everyone.
Well, thank you so much, Shino. Really, really cool perspective. It's such an interesting thing to know that that someone else is also trying to look through looking at the things that I learn every day, in order to improve yourself. Listen to other people, read snippets of stuff, snippets of like tiny thoughts and all, and then you see really short statements like this changing people's lives. Just to add to what you said, there was this statement of a guy. The guy was on the knowledge project. The guy was on the knowledge project, and the knowledge project started with a statement that said, there are they started with the guy asking a question: do you want to suffer? And then they say there's the suffering that we avoid in our lives that make it hard for us that keep chasing us all our lives. And then there's the suffering that we face that gives us the freedom we're looking for. And it's an interesting take, right? To see, to think, if you think of it seriously, you see that there's so many things we avoid in our lives, and one of them is picking up skills, trying to learn stuff that will change our lives every day. And the consistency of doing that makes it makes it really, the consistency is very, very difficult to keep up with. But when you do, and when you get used to it, then it changes everything about you. And I think that stuff is really powerful. And so, are you running away? Are you running away from something? Is there the suffering you're running away from? My advice is face that suffering. It will give you some freedom, right? So that's that. In fact, just as you were speaking, there was one last thing. Let me even share that was in the brain. That was in the. It's called Insight. He says, is from someone called Magnus Carlsen. I don't know who the person is, but the person said, I have the utmost respect for no, sorry, that's not it. Is an author and philosopher, Eric Hoffer. And this one is titled Adapting to Change. He said, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. I see this thing is such an interesting thing to write. It's like a reading from like the Bible or the Quran or something. It says, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. Right, so it's a very, very powerful thing, and I think it's ideal I think we should keep this in our minds as we proceed. All right, again, nice one, Chino. Thank you, Jacob. Anyone else who has something to add? Do you have a question to ask? Again, remember, questions cascade into a lot of insights, and if you share stuff, then you find that a lot of things will just come out from it. So please feel free to ask questions. Additionally, asking questions in platforms like this would leave something in you. It leaves the confidence to also talk when you are in another environment that is similar to this. As human beings, we often have this ability to transfer learning, but one thing we must do before we transfer learning is that we have to learn it first. We have to try it out. So please feel free to ask questions here. So while we're at it, I'm going to share a few things. I have to tell you guys something. There's something I do. I go around now looking for free texts that are free and on the internet that people need to read and would help you grow. And so today I'm going to share links to, again, like I always do. First of all, I'll share a link to our WhatsApp and Telegrams group. If you're new here, please feel free to join us here. It's called the Data Weekend. What the Data Weekend is, I know it sounds cheesy, but basically there are folks there learning data analysis. On Fridays, we have a physical community for it, and folks learning Tableau on Saturdays. We call it Tableau Saturday. And then folks who are here on a Sunday learning data science Sunday, classic stuff. So it's a weekend, right? There's somebody in the community trying to start out stuff for Thursday to learn Power BI. It's sort of like Power BI Thursdays. Hopefully she does it. Her name is Sally. I'll be happy if Sally jumps on that. She joined the community recently and she's been learning too. Right, so we have this community. Feel free to jump in on it. That's the first link. The second link I am going to share is, again, what you are watching here, the Data Science Sunday, is streamed live as we speak. But it's not just the Data Science Sunday. You could also check out my YouTube channel. The YouTube channel houses so many stuff, right? So if you check it out, you would see many stuff. You will see playlists, a lot of information there, and a lot of stuff that we have put out on the Data Science Sunday. You will also find a few things that I share from my mentorship program called the Data Science Mentor, and also check that out. I just shared it. Like, subscribe, share to your friends, your family, and your enemies. Because when your enemies figure out that you shared something that they can use to change their lives, you guys won't be enemies anymore. Right. So that's this. The next is I'm going to share the latest edition of ThinkStart. In fact, let me share my screen while I share this. I like to share Alan Downey's work. I think Alan Downey is a super great individual. I appreciate folks who puts, who do stuff for service, who do stuff for service. So this is what I want to share. I want to share ThinkStart. ThinkStart is a book that Alan I think wrote in 2014. This is it. I think if you look, originally published, look at that, originally published in 2011, right? So that's ThinkStart. So you can see it's an introduction to probability and statistics for Python programmers, right? So this is the book. But there's something that he did for this book. Now, the third edition, right? Look at the third edition. He now made this third edition into a Jupyter notebook, right? So you can buy this third edition, or you could just check out the notebooks. You can see these are the notebooks. So this is what I'm sharing today, this link, so that you can check it out. Now, if you click on it, if you click on this, it will take you to a Google Colab, which is basically a Jupyter notebook in the cloud. And you would get to, see, this is the book. See, the third edition of ThinkStart is now available, but you can enjoy free online version, right? So this is it. And the book is really great. See, it starts out, it says the thesis of this book is we can use data to answer questions, resolve debates, and make better decisions. This chapter introduces the step we'll use to do that: loading and validating data, exploring and choosing statistics that measure what we're interested in. As an example, we use data from the National Survey of Family Growth to answer questions I heard when my wife and I were expecting our first child. Do first babies tend to arrive late? And so what you have here is you can run this code, and which means you learn probability and statistics, you learn to write code, you learn to understand code, you learn to do a bunch of things. You can see stuff that we typically do here, right? I use this a lot to visualize stuff, but you can also use it to import HTML, right? And then you can read about it. Really, really interesting way to read a book. Imagine putting a book out as a Jupyter notebook and look at all the chapters, right? From 1 to 14. I think it is super huge. Now, there are other things this book offers. And I'm going to share it as a link. I think it's a book. It was due to this thing. I think I saw a free book. The free book makes it easy for you to learn the Jupyter, how to use the Jupyter notebook. I'm going to share this as a link too. I'll share it as a link. So let me share this, the latest edition of ThinkStart. I'm going to share it in the in-call message here. And then when I finish and I did this, I'll also share it in the link in the description in our live, in the YouTube live. So I'll share it there too. So that's one. Yes, so I said I was going to share a book. I'll try to share. I've shared this, but I'll share this one. This one is teaching. Let me see the name of the book. It's Teaching and Learning with Jupyter, right? I'm going to share this too. Yeah, Teaching and Learning with Jupyter Notebooks. Yeah. So I think that this book is free. I think it's out there for free, so you can check it out and just pick up the book and what. If it's your first time learning, I would encourage you to download Anaconda. Anaconda is really is very simple tool that has a bunch of packages and distributions of Python and IDEs that help you learn data science. Right. My thought is that you're here at Data Science Sunday because you want to get started. And so yeah. So these are the things we have set up on this. So please check it out. And then if you have questions. Yeah. Oh, okay. Hello, Kabir. Yes, I mentioned the Power BI Thursday. It's supposed to be started. Someone in the community had reached out and said she wanted to start that, but she hasn't really gotten started with it. So when she does, I'll let you know if she's making it a virtual thing or a physical stuff. Hopefully she does it virtual, right? So I'll share that thing. I'll definitely do. We'll try to also make everybody jump in on the data weekend, right? She's already on the data weekend, so hopefully when she does. So yeah, I'll be really excited. She was someone I met randomly on the over another community. I'm a part of the Data Science Nigeria community. I met her there, and she's currently doing her youth service at Collab, because that's part of what we do at Collab, is to find people who are super interested in tech, and then we try to engage them to be part of our community, give them the responsibility to mentor interns and also build community. So I'll be buzzing when she gets this started. She has no idea how much I'm wishing she gets that started, because I strongly believe it will change her life. All right, so when that's up, Kabir, I'll let you know. Trust me, I'll do that. All right, we have 5 more minutes to go. Anybody with a question before we jump in on what we're going to be doing today? Yeah. So I've shared a link on the book that in fact, the book I wanted us to, let me see if I can even show you guys the book. I haven't read the book, but I feel like this book is going to be really cool. Let me share. Yes. Yes, I think because I saw this, the book was out there. I think the book was out there. Yeah, I think it was out there for free. Yes, I do. So I'm trying as much as possible to share books and ensure I don't share stuff that, it takes away people's hard work. So this is the book. Yeah, so it starts with teaching and learning with Jupyter. You can see who's here. You can see my man Alan Downey. Sorry, I covered his name, but once it disappears, I'll put it out here. Alan Downey. Yeah, you can see when the book was put together. But there's a lot you can pick up in this book if you want to learn. See stuff like why do we learn? What's the Jupyter Notebook? Cost and benefits, student benefits, instructor benefits, notebook and teaching and learning. Get me? Introduction. A lot of stuff that you typically want to get to learn from the Jupyter Notebook itself, how the kernel works, getting your class going with Jupyter. If you're a learner, you'll learn. If you're a teacher, you'll teach. And you can also put together, there's a lot that can be done with it. Right? There's a lot that's been shared, and you can see if you go to the beginning of the book, there's also why it is important to use. It has this focus for teachers, but I mean, that's which you want to master, you teach. So that's a very powerful one. So I'm sharing it here, right? And so you can see how folks use it to teach and all that. So here's that. Like, jump on it. I've shared it here. Next week again, I'll find one free book there are lots of free books out there shared by people, and they've made it open source books. So I'm going to look for a lot of open source books, book for Python, data science, open source books for that help you keep your concentration, learn stuff and all, and I'll share. Right, so that is what I'll try as much as I can to do. All right, we're nearly close to 7 o'clock. So I'm going to talk about one last thing for the next 3 minutes. I know that it's pretty difficult for a lot of people who are trying to learn stuff and then thinking about how long it will take for them to get to learn it. And then start to think, okay, if this is going to take me this long, then how am I going to make it through? I don't have money. I'm starting from scratch. You know, how do I succeed in this space? Well, I will also tell you the same thing. 7 years ago when I started this stuff, I didn't also have money. And I started out with no job, and all the monies I could save up, I would always use it to pay my subscriptions at Collab, right? And I remembered something, and I tell this for free because it's important. At Collab, when I signed up at Collab, Collab had their space, had power, but one of the biggest problems Collab had at the time was good internet. If you signed up and Collab and you wanted to, the core members then will reach out to you and give you access and give you your voucher. But the internet was so bad that no matter what you tried to do with the internet, a few times it would work, sometimes it wouldn't. And I remember that I complained a lot. And I remember complaining, and Sanusi would tell me that, to be fair, when you at Collab, the internet was not the reason you are at Collab. Why you are at Collab was to build with a community. Like, it's one of the most powerful things to do is to build with a community. At the time, I didn't understand because I used to feel like, oh, this guy could just say things. I know if you've met Sanusi Ismaila, he talks really quietly, right? He talks really, really quietly. So sometimes you know, unlike me, that, you know, there's a little bit of force when I speak. He talks really quietly. So at the time, I didn't make sense of it. But down the years, though, that advice is powerful. When you work with a community, anything is possible. When you learn with people, you guys build a bond where you guys are there for each other. And that's where you realize that internet is not even a part and parcel of what you need. You need people around you to help you succeed, because that's what it's all about. Now, if at every time you think of building your data science skill and you're building to be globally competitive, and all you're thinking about is money, or how am I, you know, you just find yourself not doing anything. But if you think of it from a community point of view, where you can, you know, join a community of people, of course you have to sacrifice to keep a lot of things going. You find out that the people around you would inspire you in many ways. And that's the kind of stuff we build around here, right? It's not typically about the internet, right? Because generally I might as well use my weekends, like this next 2 hours, and learn stuff for myself. But I have learned that if you create communities around what you do and help others grow, it is one of the most fulfilling, and it puts you out there the most. So my advice is, don't focus. I know it's easier to say right now. I know it's enough. You roll your eyes and say, this guy has not seen suffering. That's why he's telling me to just step out. But that's the way the world is. you have to make out time, you have to do a lot of sacrifice, and you notice that the growth just keeps going. I recall how at a point when I stopped focusing so much on the internet, I started to see that there were a lot of great people at Collab. I tell you, these guys are now, at the time, they were just regular folks, but today they are startup owners. There's a banker, the owner of a bank at Collab who, whenever he comes to Collab, is like a regular chap. He is a regular chap, right? But we always, when we see like the Aigimokwe, the late Herbert Wigwe, the current CEO of GT Bank, or the CEOs of First Banks, and the founders of and founders, investors, CEOs, leads at OPay, Sudo, Number, Kuda, all these guys are regular chaps. I promise you, they are regular chaps, and all they do is that they work hard every day just to change the lives of other people, and it is rewarding. So that's what community is about. If you think about it, about helping others grow, you realize how much it will change your life, and I can tell you that. So try as much as you can. Don't think too much about the little you have now. They say the world is for people who learn, and the learned would make use of a world that does not exist anymore, while others will be grappling. So on that note, let me introduce you to the second session of today's episode 139. And today, our focus is going to be on, yes, yeah, Kabir, I noticed it, okay, first and foremost, shout out to Kabir Olawale. Like, I have to say that, like, always listening to the way you give your takes, right? It's inspiring, right? And I noticed that you're a product of that. That's why you pay attention and try to join community stuff. So I appreciate it. So when saying that you're a product of community learning, I swear I don't doubt that at all, because I noticed your engagements and all, and I appreciate it a lot. So well done. Right. So again, guys, let's keep up this part. Being in the community and learning is super, like, it's awesome. Then trying to jump on the community and help others learn, that one thing will take you to a different level. I've seen a lot of people. There's this guy he works at Data Culture. What's that his name? Fabi. He was one of the first data engineers at All School Africa, data engineering track. And one of the first data analysis instructors started her data analysis journey by joining Fabi's community. It's so interesting to see that she eventually came and met the person that inspired her to get into data analysis. And the guy was just doing his thing and just helping other people grow. So I think it's super, super huge. You're part of a community just like this one. Think of what you can do every Sunday. Data Science Sunday is not just me. It could be anybody. If you have stuff you want to share, please feel free to share. I also encourage a lot of people to do that. So if you can, please, it will change you. It's change you. That which you want to master, you teach. All right, guys. So let's get in with what we have for today. Today, we are going to be looking at simple unsupervised learning examples. So for the past 5 episodes, we've been looking at introduction to machine learning, right? And I'm just going to do a little recap of what we have done. Just a little recap of it. So machine learning, yeah, so this is it. Look at where we introduced this. Machine learning is for like a very intuitive way is is a departure from traditional programming where you take an input, write code, and get an output, right? And the code you're writing is basically rules. Now, machine learning is take an input, and the input is data, right? Then build a model. This is the model. The model is going to house the things the rules, the pattern, the ability to learn from, past information, and then you can get an output. And one huge thing that it does is to give you competitive edge. Imagine that you can predict what will happen, in the next 3 or 4 quarters. If you can do that, have like 75% accuracy on what will happen in the next 2 quarters. Knowing that there's a lot of variability in the system and a lot of volatility, you have a competitive edge. Now, to get into that world, using machines to teach us how to do stuff, we typically need to understand the principles guiding the application program interface that helps us build these algorithms. And so this is just the hello world of it, right? So we looked at that, which is the body of algorithms that help us build these models. Then we also looked at the category of machine learning, the categories that mimic the different aspects of building these models, which are label-based techniques and group and cluster-based techniques. There are popularly known as supervised. They are popularly known as supervised and unsupervised machine learning. Right. So with supervised machine learning, we are predicting. We get to predict labels. So if you have a body of data which are explanatory variables, they are called explanatory variables, or independent variables, right? Or from our definition over here, they are inputs. Now we can take these inputs and then predict either age, we can predict price, we can predict classes like yes or no, fail or pass. We can predict stuff like that. And a lot of these activities happen every day in our lives, right? Like if you one very popular one is when we look at our emails, you see how well our inboxes can our inboxes can determine what's spam. If you look at your email, you see different things in our email that tells you, oh, this is spam, or puts it in one category. You can put it in socials or put it in updates. How is that done? Right. So these are either classification or regression. Regression are like numbers, predicting numbers. This one predicting classes. So part of what the conversation we're having is to look at these things in very simplified ways and to make sense of them. So we've looked at this introduction, looked at technical definitions, looked at the categories. We also visualize what the categories look like. If we're going to take inputs for classification, then it tries to, find out the different classes that exist and then try to predict these different classes. Then we looked at regression, and regression is where we have inputs and the outputs you're trying to predict are numbers. They are continuous values. So here you can predict how much, you can predict stock prices and stuff like that. Then we went on to also look at unsupervised techniques. Now, unsupervised techniques they do not focus on labels. They focus on clusters and dimensions. And so we just looked at them in a very simplified way. Then we went on to look at the API, the scikit-learn, the documentation, the body for these algorithms and help us build it, right? And we looked, it's a Python library, implementation of ML algorithms, clean, uniform, and streamlined. And so that's another part we looked at. Then scikit-learn has something called estimator APIs. We use them to build these models. However, they have rules. They have the way the data needs to be represented that makes it easy for us to, go on to build predictive models. And then we went on to show examples of how you can look at data, know the explanatory variables or the features, and understand what the labels are. Right. And then also look at data representation with scikit-learn, which is really important. So we're talking about samples, which are like the targets, not like, and then we have n_features, which are our columns and features, because data is broken down into 2 dimensions, and they're called the feature matrix and the targets. So this we try to visualize them, because these guys are the features, and then of course then the targets. Look at them over here. These guys make up the targets. These guys. Then we also have a visual on how the data representation should look like. Then when we now went ahead to represent it in data so that we know what it looks like. Then the scikit-learn estimator API has guiding principles. We looked at these guiding principles because it is important to understand these principles. They are the first principles that help us know what we're doing. Then the steps on the common steps on using these estimator APIs. Now, with all this done, right, we now went ahead to now really build really simple supervised learning examples. We did a simple supervised learning examples, looking at all these principles. Then when we are done, it's now a chance for us to now build simple unsupervised learning examples. So this is where we are. This is basically that. Now, as we do these things, I want us to understand that it's how it relates to life. Our focus should not be on the code we write. Our focus should be on how this can be implemented in reality. For free, I'll tell you, at Collab, we have a project. We have a project around cybersecurity, right? And part of the project, we are building, as part of the project, we are building an ML model that can, just hold on a bit, we're building an ML model that can predict, it will take tweets, and then build a model that can flag hackers online. When you go online, you see people saying, oh, contact us if you have bank issues. Banks will always tell you not to share your PIN, or they will never tell you that. But there are hackers out there who will pose as banks online, and if you're having problems, they'll tell you to send a message to their WhatsApp. That's how people lose stuff. So there's an ML model being built that can flag this, and that when it flag it will put them into different classes. So it's a thing. Right, but that's the reality. That's trying to solve real world problems rather than just writing it as code. All right. Yeah, so that's one way we're looking at it. So today, what we are going to do, is to look at a simple unsupervised learning example. Now, with unsupervised learning example, our focus is on clusters, and the focus is on clusters and dimensions of data. That's what the focus is on, right? So it's either we either look at our data as clusters, or we reduce the dimensionality of our data so that we can find insights, right? And again, we already have the data here. So we created the data x underscore iris. Yes, this data is the one that has the n underscore samples, n underscore samples, this one has n underscore samples and n underscore features, which basically looks at which shows us our which are independent variables or our explanatory variables, right? Then we now have y underscore iris. This is now our n. This is basically our n underscore samples here. But remember that our focus isn't on the labels. We're now looking at the data generally. So with when we are looking at unsupervised, then our focus is on clusters and dimensions of data. Now the idea is we may see insights when we visualize clusters, or we may get insight when we reduce the dimensions of our data. And so today we're going to be looking at a dimensionality reduction technique. So this is what we're going to be looking at. A simple dimensionality reduction technique. Yeah, a simple dimensionality reduction technique. That's what we're going to be looking at. Now, the task of a dimensionality reduction technique is centered around determining whether there is a suitable representation of the data you have, but that maintains its essential features. It's like you have so much information, right? But you need to reduce it, right? So that you can get to find out if there's any insight you can get. So that's what it is, right? So what we do is reduce. It's centered around reducing the dimension of data while maintaining the essence of the data. So that's one thing, right? Why maintaining the essence of the data. Now, to get this done, we're going to use a dimensionality reduction technique, which is called PCA, Principal Component Analysis. Principal Component Analysis. So we're going to do, right? And it is known, in other words, it's known as a linear dimensionality reduction technique. Linear dimensionality reduction technique. Right, so that's what it is. Right, so what Now you see that we already have our data existing. So once we take our data and we let this model, let this model, we let the model, we put our data into this model, it's going to find a way to see, we're going to find a way to reduce the dimension of the data and maintain its essence and see if we can find anything inside of it. So that's what we're going to do. So remember that if you had been in our sessions, I've maintained that there are steps that we use to build this very simple model. Look at them. See these common steps in using these APIs, these estimator APIs, right? For regression models and classification models, we choose our model hyperparameters by instantiating it. We arrange our data into the way our desired setup. Then we fit the model. Sometimes when we fit the model, we can predict or we can transform the data. So it all depends on what we're going to do. So we're going to still use that here, right? We already have our data. So the first thing we'll do, which is the steps which we will generally follow, is to choose the model class. This is the first thing. We choose the model class. And here, the model class here is the PCA, right? So how do you choose the model class? There are so many. There's the scikit-learn documentation. With the scikit-learn documentation, look at it. Scikit-learn. The scikit-learn documentation. Look at it over here. Yeah. So you can see what it's about. You can see in it's machine learning in Python. Simple, efficient tool for predictive analysis, accessible to everybody, and reusable in various contexts. Built on NumPy, SciPy, and Matplotlib. Open source, commercially usable. And you can see they have classification, regression. You see that I mentioned clustering. I also mentioned dimensionality reduction, right? So you can see there's a bunch of things you can do with it, right? And you can see those that use scikit-learn. You can see the different organizations. There's Spotify. They use scikit-learn too. So there are different stuff out there. So you can also check this version out, and you can see even for dimensionality reduction, you can see we already have the PCA. This is the guy that we're going to look at. Exactly, typically what is here, that's what we're typically going to do, right? So that's what we're going to look at, and how we'd use this. It will let you know how we can use this. There's a breakdown on a lot of things you can do with it. So feel free to check out this documentation, right? I'll drop this documentation here in the in-call message. And then I'll drop it in our WhatsApp groups, WhatsApp and Telegram group. Where is our group? All right, so I've just dropped it in there. So now, so that's what we have. Now the next, let me now go back and just do a very simple one. Now for us to choose PCA, we have to say from sklearn dot decomposition import PCA. And so what we'll call this, so we've chosen the model we want. Whenever we run this, what we have done is that we've introduced this, we've imported this model into our namespace. So it's now inside our namespace. That means if I just basically say PCA, you see PCA. If I put a dot, it will tell you all the things that are inside your PCA here. So that's just basically what we've done. Now, the next thing we want to do is to instantiate the model. We'll instantiate the model. Now, to instantiate the model, we'll just basically create a variable name called model, and inside we'll call PCA. Now, with PCA, it comes with something called sensible defaults, right? Right now, we are not, when our focus, we are not on the focus of how to tune our defaults, right? But they come with very sensible defaults, and we can use very sensible default to get started with. Now, the first default we're going to use are end components. Like this end component is explained here. It's like the number of components to keep. So we're basically trying to reduce the data we have. So we say maybe we're looking for 2 components, right? The essence of it is to maybe bring it down to 2 2 dimensions to see if we'll still find any essence in it. Right. So with that, we can now choose this and say n underscore component. We just say 2. Right. So here, if we run this, we have instantiated the model. So this model you see here carries this guy over here with this very sensible default, this parameter we see here, this hyperparameter. Now, the third thing is we would fit the model to the data we have. Now, remember that our data here is this guy over here that has like 1, 2, 3, 4 dimensions, which are like the 4 features it has inside. And so what we do is basically say model dot fit, and inside of it we put x underscore iris. So once I run this, right, it's already fit the model inside. So basically it has consumed the data we have, and then it has applied or implemented this. It has applied, or it has oh, sorry. The annotator has chosen to stop. Let me just restart the annotator so it makes it easy for us to work with. Yes. So for this sensible default here, you can see it has implemented, it's sort of like I've set it into consumed the data and then fits whatever that model to it. Now, the fourth thing we're going to do is we're going to transform our model. Now, before we do the transformation of our model, right, we've already seen this is the data we have, right? So we're going to say transform our model, and we're going to call this iris underscore 2D. That's what we're going to call it. And inside, we're going to say model dot transform, and then inside we're going to put x underscore iris, and then we'll run this. So this is what we call, this part of it is called to transform the data. And so we'll run this over here. Now, let's check out what we have as iris underscore 2D. Look at that. This is what we have. You see what it is, right? So it's sort of like put this into, if I put a square bracket here and then say 2, it just brings out like these 2 guys here. So you can see this is what the data looks like. Now, we already have our existing data, which is our original data. Now, remember that we split our data here. This is the iris we have. We've converted this thing into 2 dimensions. Now, what I'm going to do is I'm going to bring the original data as is before, and then we are going to sort of like add this new data to it. How do we do it? At first, when if we come over here in the beginning of the data, we had iris data. This is the original data here. So this is what I'm going to bring down here. So this is iris underscore data. This is the original data here before we split them into the transform. We split it into n underscore samples. So this is the original data. Now, with this original data, right, I'm going to introduce these dimensions that we have created here. I'm going to introduce these dimensions we have created here. And then we're going to add them to this. So we are going to have like it added to this place. That's what we're going to do. And now to do that, I'm going to come over here and say iris data, which is this data you just saw here. And we're going to create a new column. I'll call this PCA1. Right? And inside PCA1, I'm going to take iris 2D. And then I'll call this first guy. You see this first guy? You see that we put these guys here. So what we have here is it's in 2 dimensions. So I'm going to say this first guy, I'll put a square bracket here and call the first dimension, which is with 0. And then I'll add it here. So it's going to, that's one of the first column, the columns we'll have here. So that's 1. I'm now going to do the same thing here. I'm going to copy this. But this one is going to be 2. And this one is going to be 1. So then I'll run this. So which means that if I call iris data, the new dimensions we have created will now be added to it. So you can see PCA1, PCA2. You see this minus 2.68. This was what was here. Look at it, minus 2.68. You see 0.31. This was it here. So just so it's, it's not something, we didn't just do something new. It's just we added this here. Now, the next thing we're going to do is we're going to visualize the data. And our focus is going to be on the new dimensions we have. However, we're going to we're going to place other focus on it just so that we can know if our dimensions were able to bring out our new 2 dimension was able to bring out anything for us. Now, if we take a look at this data here, you see that if we're going to be focused on labels, these guys are the things we'll be looking at. And remember that we haven't done anything, we're not looking at it based on this label. We just want to see if there are some insights that we've gotten by reducing it to 2 dimensions. So to that end, what I'm going to do is I'm going to visualize. I'm going to use SNS. I have called this before. I have it already as a model, which is the Seaborn data visualization, statistical visualization model. Then I'm going to say SNS.L this plot. So this plot is used to plot data and regression models, and then we can take different models and fit them across a facet grid, right? Which you can see it in different ways. But what we want to do is we're going to pretend like it's a regression model, but it's not a regression model per se. What we already have is we just want to look at the dimensions. So the first thing we would plot is we'll plot the x-axis and we would plot this guy, the x-axis, this guy here. So that's what we got here, this first dimension. And this first dimension here is is an array. You can see they're an array, so we just put them here. Then y-axis is going to be PCA2. Now, we want to look at these dimensions and see if we can bring out anything. So we're going to say we want to base the colors off of this guy, just to know if anything was in this, if we can find any insight. If we break them into 2 dimensions, are there any insights? And if these insights are there, we want to see if it can bring out anything around species, because the iris data set is typically data that you originally used to predict species by looking at their different features, at the different species of the iris flower by looking at their different features. So here I'm going to put species. Then next, I'm going to reference the data we have. And remember, the data we have is this iris data. So I'm going to say iris data. Now, this by default, if we look at this guy here, there's this feature here called fit reg. Now, what it's saying is it wants you to fit a regression model. By default, it will fit a regression model. And we're not fitting a regression model, because remember, regression models focus on labels. Rather, we're trying to we're trying to look at the dimensions created from our dimensionality reduction technique model. So with fit reg, would make it false. So there's no need for that. Now, next we're going to do plt.show, so we can look at what we have visualized here. So now you can see that these were the 2 dimensions. This dimension here, you can see this is over here. You can see these are the dimensions. And you see that when we set it up by saying, look at the species, it was able to extract 3 things. Right? It was still able to extract 3, even though it put it into 2 dimensions, right? It tried to fairly separate them so that you can see that there is 1 dimension here, and this dimension over here. But it was able to get out this guy and this other guy here. And inside, you can see that it sort of figured out that there were like species there, but even though it was not basically looking at that, but by reducing the dimension, right, it was able to sort of create a class in itself. So this is what it is. Now, what does this actually do? What does this mean in reality? It means that the data we have generally, we may not almost always predict if there's anything going on. We can basically look at the data and find out if we have some kind of representation existing that we don't know. We can do that by either reducing the dimensions of the data and seeing if there are things, because with unsupervised learning techniques, it leverages on visuals to see if there's anything new with the data. Next week, we're going to look at clustering, where we can group, instead of dimensionality reduction, we can look at clustering. So that's basically what we have for today. Now think about the different things we can do with this, the different possibilities that you can do. If you have data, large corpus of data, reduce it in dimensions and see if there's anything that exists in it. You can use it. This can also be used when you're doing your machine supervised learning technique, when you want to see if there's any sort of like any insight in your data. So this is basically what this is. I feel like we take these things for granted in the period of AI, right? That's why you see a lot of people are saying, "Oh, I want to learn AI. I want to learn AI." But these things are like fundamental to AI, and then building on that. Because if we go back to if we go back to the very beginning, where we defined what machine learning is. Let me go to the very beginning here. To the technical definition of machine learning. Look at, let's read this. It says, and I think I copied this straight off Wikipedia. It says, machine learning is a branch of artificial intelligence that focuses on developing systems that can learn from data and improve their performance on specific tasks without explicit programming. Essentially, ML algorithms analyze data, identify patterns, build predictive models to make decisions or predictions with minimal human intervention. So it's a branch of AI. However, what I've noticed is that folks are genuinely interested in AI, but nobody's genuinely interested in data science and machine learning. So you hear people just say, "Oh, I want to learn AI. I want to learn AI." All right, good. Let's start with data science, and everybody will tell you, "No, can't I actually do the main AI?" So yeah, these are like the fundamentals for how this whole AI conversation got started, and it's really important to know to have this fundamental thought process. So yeah, to recap, what we have looked at is a fundamental dimensionality reduction technique in the unsupervised machine learning category, where you take data with focus on reducing the dimension of the data to find out if you can find out if there are other insights in it when you visualize it. And we also used the 4 to 5 steps of using the scikit-learn APIs, estimator APIs, which is choose a model, instantiate the model, fit your model to the data, and either predict or transform the data or predict from the data. And in this one, what we did is we did the transform stuff, because it is here we're using a dimensionality reduction technique, but not predicting. All right, that will be that. We have approximately 15 minutes to go. Do we have questions? Please go ahead.
Good evening, sir. Thank you very much for what we have learned today. Yeah, recently before when we were starting, I wanted to ask you about the cybersecurity collaboration with Collab Hub. So my question is that, in that cybersecurity tool, there are broad niches. Let me put it like that. So there are broad niches that is inside cybersecurity if someone want to learn. But I just want to ask you, maybe as a mentor, or how do you feel? What's the roadmap you think someone can follow when someone want to learn cybersecurity?
Okay, so generally, right, I wouldn't typically, I typically don't know much about cybersecurity. However, there have been a few things you can pick up from the cybersecurity side of things. Like you need to learn the tools needed for understanding things like vulnerabilities, being able to extract information, know what is, you're typically like a hacker yourself, but definitely the hacker that does things in order to keep certain systems safe, right? But I'm not I'm not really so great on it. So I'll basically just give you the general sense of it. You're basically trying to learn how to, to figure out the vulnerabilities that exist in systems and know how well to sort those vulnerabilities, which are either from external factors or internal factors, right? and here's me deviating from your question, so you don't think I typically just run away from it. But from a data science point of view, the features you can use to figure out if a system is vulnerable or if it is fraudulent or anything, they have data around it, and I think I'll be looking at those areas and trying to understand those aspects so that you can be able to say, okay, if I see certain features, does that tell me something? So that's the best I can tell you. But the roadmap to learning cybersecurity, you can just Google it and then try to bring that out. But I know there's something that is certain. One language that is typically needed for it is Python programming too, right? Because we had to review the curriculum that is being used for cybersecurity, and we had to introduce Python programming inside of it. And we're also trying to connect with schools out there trying to teach cybersecurity, just to be sure that for the focus in Kaduna State, we are trying to ensure we have some sort of like a cybersecurity like a community, broad one, that ensures that we are building to secure all the monies that people are making, especially in fintech and in banking. So yeah, so that's the best I can tell you around that. But roadmaps at this point, I don't know, but you can look it up online. A simple stuff. If you're on ChatGPT, you can use ChatGPT and say, please, can you share me a simple roadmap for anybody getting started with cybersecurity? That will help.
Yeah, thank you very much. I thought you've already, maybe you are in the intermediate level. That's why I brought up the question.
I
Thank you.
don't I don't know about cybersecurity that much. I sincerely don't. It's not my area of knowledge. So all right. Questions? Do we have questions? Do we have questions? Anyone with questions? Questions? Well, in the absence of questions, we're getting into another week. We're already in another week, and remember, just like I mentioned in the knowledge, what we mentioned in the knowledge project. I want the knowledge project. Let me read it out again. It says, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. Right? So please remember that. Do put yourself in a position where you will improve today, improve tomorrow, improve next tomorrow, improve on Wednesday, Thursday, and Friday, right? Because every moment is an opportunity for you to make your future easier. You've got to pay the price right now, right? Don't run away from the hard things, right? So you don't get to make things, be the one that is always running away from things. What I have learned from my experience at Collab and with the guys who are the guys who came and invested in Collab and put on a lot of things and tried to make the best out of it, that they invested, they made sacrifices yesterday so that they can have an easier life today. And these people, one thing we have in common with them is that they have one head, just one head, not two, not three. We're all human beings. All right, guys. If you are Collab, if you are in Kaduna, please visit Collab Innovation Hub. It's a super community out there. If you're not at Collab or you're not in Kaduna, please, you can always join us on Data Science Sunday. If you are interested in joining a virtual learning setup, there's the Data Science Mentor Program. I founded it. I build on that. So please feel free to reach out to me, and I can walk you through what that is about. All right, guys. Anybody asking any questions before we wrap up for episode 139, the 28th Sunday of the year? Any other question? If nothing, looking forward to episode 140 and the 29th Sunday of the year. That will be next week Sunday. Until then, all the best and keep doing what you are doing.